ACAN are pleased to be hosting our 19th event on building with natural materials, and this time we're going to be focusing on prefabrication. We've got some really good people tonight from across the industry presenting, followed by the questions. So before we kick off, I'm sure most of you already know all about ACAN, but for the benefit of anyone who doesn't, we'll just give you a very brief introduction about who we are. So ACAN is an open voluntary network of individuals in the built environment industry. We started in 2019 with a vision of how we could work autonomously as a collective of individuals in order to make rapid decisions and respond quickly to the climate emergency. So we have three main aims in our manifesto. They are decarbonise now, ecological regeneration and cultural transformation. You can read more about that in detail on the website and also here if you're pausing the video. So tonight's speakers, we're going to hear from Craig White from Agile Homes, and then after Craig, we'll be listening to Barbara Jones from Eco-Cocoon, and then finally we'll be joined by Will Kirkman from We Build Eco. So I'm now going to hand over to Aurora, who's going to introduce each of our guests.
Thank you, Anna. So, first speaker of the night. So we've got Craig, and Craig is CEO to Agile Property and Homes. Agile delivers low carbon, affordable homes to those in housing need using low carbon modern method of construction, built and scaled at pace. The climate emergency drives Agile's design and development of its products and services, and carbon capture materials are used in the fabric of its system to ensure that operational energy and embodied carbon is minimized. Over to you, Craig.
Thank you very much. Good evening, everyone. I'm just going to switch over to share and bring my slides up. Go into play mode. So Aurora, thank you very much for saying all of that. That was my strap line, so I'm going to move quickly on and past that. So it's time for us to build with carbon, and it'll become clear exactly what I mean by that as we go forward. So we live in a time of multiple crises. I'm only listing two here, but the climate emergency and the housing crisis, and these are the two that we specifically feel we can address. And of course, pandemic, war in Europe, Eurovision, everything is very complex today. Some facts about the industry: 60% of all materials by weight are used in the built environment. So as architects, engineers, and civil engineers, we specify an awful lot of materials. 12% of all global emissions are embodied in winning those materials, processing those materials, and delivering them to site. And despite landfill tax, 20% of all materials by weight delivered to a construction site can end up in landfill. So buildings impact, and our job as architects, engineers is to optimize and minimize what we do. So this came out in 2021, which shows that as a species, we have now managed to create more anthropogenically mass materials, concrete, tarmac, bricks, etc., steel, everything, than the rest of the biosphere on the planet. So we are naked apes who have changed at a profound level the way our systems on the planet work. And the biggest shift we're seeing, and the one that appears to be rapidly changing than our models might have suggested, is climate change and global warming. So I was asked to kind of set the scene. So modern methods of construction, what is that? And of course, everybody uses a variety of languages about what they do, whether you're talking about modular, modern methods, prefabrications, systemized, DFMA, design for manufacturing assembly, plus, which means reuse at its end of life. So it's complex, and we're all kind of navigating our way through all of these definitions. But the Farmer Report thought to put all of this into order, and there are kind of 7 categories. I will just explain the first 3. I won't go into additive and robotic, but effectively there is structurally load-bearing building systems, either in 2D or 3D forms. then the structural systems that make up a building in 2D forms, and then pre-manufactured components, which may or may not be walls, but could be utility cupboards and the systems that would go in a building. And we do 1, 2, and 3, and there are variants, but that's the technical definition of what prefabrication is. And if you click on the link, which will come out later after our talks, that is the link to Mark Farmer's report on the construction industry. I'm working with We Can Make. We helped co-found that here in Bristol, and part of what we did was do a definition. Okay, so how does all of that stuff break down? And I'm not going to go through each of these, but it comes in any type of material. It uses steel, concrete, timber, and other combinations of natural material, and they can be formed as open panels, or they can be all the way through to fully closed panels, and then all the way through to 3D volumetric shells, and then all the way through to curtains hanging and a pint of milk in the fridge. You can actually prefab and MMC your way to complete delivery solutions. So the key thing also I want to talk about is materials, and why would natural materials be a better set? And as architects, engineers, and designers, we need to understand a lot of numbers to be able to work out what is the data baseline from which we can work. So materials all have mass, that's the weight of things: timber, concrete, and steel. So going from lighter to very heavy. And of course, we use them in different ways, and we need to then understand what's called their conductivity, the speed by which energy or heat will flow through a building material. So wood is very poor at conducting heat, steel very good at conducting heat, and that's why we have steel frying pans and not wooden ones. And then capacity, that's the ability for that material to then hold on to a volume of heat energy. And I won't even attempt to read out what the CP joules per giga minus 1 actually means. I'm just an architect, I'm good at coloring in, not so good at the numbers. But the more interesting one now is for embodied CO2. So if we look at steel, from raw steel all the way through from a mine, a bauxite mine for aluminium, or a steel mine, it's 12,200 kilograms of CO2 per meter cubed. But we can use steel in interesting and long span ways. A concrete is not a high embodied material per se, but what it does, the problem with concrete is the volume of concrete we pour. So we pour about 8 billion cubic meters of concrete every year. So that's roughly 1 cubic meter per person on the planet each year. And then the embodied carbon of timber, interestingly, has a minus number, and there will be people doing life cycle analysis and say, well, you've got to do the net to gross calculation. But effectively, natural materials are powered by photosynthesis and eat CO2 every time the sun shines. So this is what powers our system. There's a sun, and some of us have just enjoyed capturing pictures of the aurora. There's a solar flare. And for the long term, that's the energy system for what we are going to be doing. And then about 4 billion years ago, a couple of life forms on the planet kind of got together. One of those was chlorophylls and the other one was plants. And they combined in a synergistic way to be able to be powered by solar energy in order to capture CO2, and photosynthesis then splits the molecules of carbon and atom, rejects oxygen to air, thank you very much, and then takes carbon and puts them into complex sugars. And it's a very, very powerful system. You can see this is a sinkhole in South America. It's 200 meters deep, and there's a forest at the bottom. As we go down into the cave, it gets less and less. So what's happening? It's this combination of two living entities, chlorophyll and the plant itself, and it's these that are splitting the atoms. It's a little bit more technical than that, but we don't have time to talk about that. So we've got an engine, we've got the means of getting minerals into our plants. But if you think of a tree is actually a dual root system. There's one in the ground pulling up water and minerals, but its food source, its carbohydrates, come from CO2. So the second root system is our leaves that are collecting that. And without that, there is no growth in photosynthesis. So CO2 is part of a natural cycle on the planet. So let's just have a look. And just to repeat the numbers, a cubic meter of European white pine, for most of us, that's pretty much everything we need to use. It's consuming 742 kilograms of CO2 equivalent per meter cube of timber created, usable meter cubes of timber. So it's got no CO2 in it. It's now carbon forming parts of complex sugars that make up cellulose, hemicellulose, and lignin. So that's the kind of technical explanation of this. And then straw has a different metric, grows very fast, it does it annually, and it eats 1.68 kilograms of CO2 equivalent per kilogram of straw created at dry weight. So everybody says, how can it capture more weight than it is actually physically? And that's because it's rejected the oxygen of the CO2 and it's now only keeping the carbon. So those are our ingredients. Can we work with straw, timber, and lime render? There is no lime in our build systems, but we work a lot with lime render. And I know that's barley before anybody points that out to me, but we can also work with barley straw, but predominantly wheat straw. And then we have some screws and glues. We developed a system of manufacture which borrowed from lots of really great work from traditional construction, and then we brought it into what we call a flying factory. So you can see a John Deere combine harvester in the corner there, and then these are some of the raw ingredients. There's lime waiting to become render, there's straw waiting to be the insulated fill, and then we have CNC, computer numerically controlled cutting machines that pre-drill, pre-cut the frame, which will then be the load-bearing frame of our build system. So effectively, we're going to build a big picture frame and we're going to put straw in. We have to know what the settlement rate of straw is, but we've designed the opening into which we put the straw to be less than the bales that will go into them. So we did about 24 months of settlement tests. We're not the only people to have done that, but that means effectively it's a pre-stressed concrete straw build system. And then over time that relaxes, but it doesn't drop below the frame. Those gaps are for windows for our project up in Yorkshire. And this is just an animation of why prefabrication is good. So I'm just going to turn that down. So this is us doing the bell house at Bath with Pete Walker at Bath University. We've done a lot of primary research. This is day one. Those are the prefabricated rendered panels going in, cross-laminated timber floor plates. That's day one. Day two, we put on the top floor and we actually built some of the windows in. And by lunchtime on Wednesday, we had a watertight building. So that took 2.5 days, 14 years ago. And today we can do a 1-bedroom house in 5 hours. So prefabrication is fast. Everything is done off site, which is dry and secure. The toilets work and the coffee machine occasionally has coffee in it. And so this is the Bell House at Bath. And this is a combination of lime, straw, and timber, plus other materials for the windows, etc. So that was built 14 years ago. And how much carbon or CO2 equivalent have we actually captured? So inside all of the materials, all the timber and straw, and we don't count the lime render, there's a little bit of debate about whether lime is fixing more carbon, so it may not have, it may balance neutral, but it may not be negative. There is 34 tons of atmospheric CO2 once in the atmosphere, now locked and stored and banked in the building as carbon. And that's the equivalent of a photovoltaic array running for 45 years, a 2-kilowatt array, which is around 25 years longer than what we understand PV service life would be. We then went on to, after the Bell House at Bath, we then co-designed the Lilac co-housing project with Paul Chatterton, Tash, Alan, and others, the co-founders there. And this is 20 family homes, all made out of straw, and we were particularly delighted to be selected by the United Nations as this being one of a number of projects around the world that was an exemplar of their SDG 17s. These are some of the people co-housing, a really lovely group of people, predominantly middle class, predominantly waged and diverse in background and age, but largely middle class. And but nonetheless, this is a mutual home ownership society model, an AMOS, and everybody in that picture plus others are shareholders in a co-op or AMOS as they run there. Good thing about that, not about the people, but about the energy, is these are measured numbers from Lilac itself after post-occupancy evaluation, which is quarterly heating bill for a one-bedroom apartment is £20. This is pre-pandemic, prices of energy has changed, and £50 for a 3 or 4-bedroom home, about 90% less than the average for Leeds. And this is actually performing at just above passive house in terms of performance, so about 100 kilowatt hours per meter squared per annum. We do a lot of research. Others will have been involved in research as well. And there's a great website called isobio.com where we're working with other materials. So we work with hemp, coconut shells. We've done all sorts of research. And this was a European funded project where that is hemp fiber insulation, and Indie Nature are now producing that in the UK with some support from Scottish government. And then this is hemp shiv bound using bio-based binders. So if you take a natural material and put it into epoxy resins, you've probably wasted your time. If you take a natural material and bind it with bio-based or natural binders, you've done a better job immediately, and there's an end-of-life story that allows them to be reused and recycled. The website you can visit. We then certified that build system with Passive House, and we worked with Ollie Style, not called Practice, yes, now called Praxis, out in Barcelona, and we work with a number of fantastic partners. Then there's not only bales, but there's also chopped straw, and we took a decision also to not only continue with bales, but also to look at chopped straw, which gives us more opportunity to change the width, the height, the density, the moisture content of our materials. And we then built a build system that also combines chopped straw with compressed straw board by EcoPanely, based in the Czech Republic, and Agile is the importer for that build system. So if, that board system. So if anybody wants to use those boards, we can put you in touch with EcoPanely to use that. We then built a whole home out of it, and this is now about affordability. And so this is what we call TAM. We did it on land that was free and hidden in plain sight. It's triple glazed, super insulated. We then invited the Mayor of Bristol to sleep in it. Partners were the North West Media Centre and the We Can Make project. We helped co-found that project. We invited the Mayor to sleep in it. He sofa surfed, and Bristol City Council is now a partner in the project. The thing about TAM, it's movable, which means we can take it and use it in a variety of different settings in interesting and innovative ways. So how much carbon or CO2 equivalent are we now looking up? So that's a kilogram of CO2 at atmospheric pressure. And then in the background, you'll see this is the amount of CO2 visualized using 1 kilogram balls of carbon. That's the compressed straw board. There's the timber structure, the skeletal structure of the building. That's the large cladding and everything else to finish off the building. And while that's a smaller number, it's more CO2 equivalent captured per meter squared by about 50% more. So, and that's the equivalent of a car traveling about 120,000 kilometers. So we have, along with many others, we have a method of doing carbon capture. Nature does that, but we can do the storage, and we can turn the built environment into a natural carbon sink and store carbon in the built environment if we choose to build with it. So here's some examples of some projects. This is for Emmaus Homelessness Charity. We've got them permission to build 15 1- and 2-bedroom homes, kind of TAMs on end, as well as horizontal, not quite TAMs on end, they're properly space standard houses built on top of their roof, because we are also about 1/3 of the weight of conventional brick and block construction, which allows us to design and build in very different ways. Here's phase one of that project. These are 2 Airbnbs run by Emmaus Companions. Emmaus Companions are formerly homeless people that work with the charity, and the charity work with them to provide them with skills and training. And the whole charity works as a social enterprise. And if you want to stay here, Lakota Nightclub is just in the background. Anybody been to Bristol and been out clubbing late at night, Lakota would be one of the places you might end up. But you can now book these things. They're run by Companions. They're marketed by Companions. The changeovers are done by Companions, and that is 2 chopped straw insulated pods up on stilts, jumping over a wall. And we're doing several projects now on stilts. And you can see there is a birch tree that wasn't killed. So we don't pour concrete anymore unless we absolutely have to. So the rule was we don't do concrete, and then we manage a retreat from that position. Screw piles allow us to not kill trees. And this is another project we got planning permission for in Bristol for our old offices before pandemic hit. 13 1, 2, and 3 bedroom homes as a community on top of a 6 and 7 story. It's 4 stories at the front here, but 6 and 7 at the back. And then a little plug for a date in your diary. On the 7th of November, we're running our Radical Housing Conference, which we've now run for 3 years. This is our 3rd year, and please do come and see the other work we're doing in terms of housing and radical housing. I'm now trying to stop sharing. There we are. Okay. I don't know whether I kept to time, but I was going fast. I'll stop there. The world of prefab with natural materials.
Thanks very much, Craig. Aurora, would you like to introduce the next guest?
Thanks, Anna, and thanks everyone. Next up, we've got Barbara, and so Barbara is the founder of the School of Natural Building and the UK Preeminent Straw Bale Building Authority. She has decades of experience with straw bale building, clay and lime plastering, building physics, and she's leading work on building sites across the UK and Europe. Barbara set up Strawworks, now called Wellspring Architecture, which is a bespoke design company specializing in buildings made of straw and other healthy natural materials. Barbara is now a technical consultant at EcoCocoon and an innovative wall system making the best of natural materials. Over to you, Barbara.
Great, thank you very much. Good evening, everybody. I'm just going to share my screen with you so that you can see what's going on here. Hopefully you can all see that. And if I can get it to make it do the whole thing. Yes, good. Okay. Can everyone hear me all right?
Yeah.
Yeah, good. Okay, great. So I want to tell you about another system that works with straw, just as Craig's does. So I don't need to go into all those details about straw that Craig very helpfully sent to us, because he's already said that straw does, well, that straw might do everything we want it to do, but my screen, yes, there we go. I want to tell you about the EcoCocoon straw panels and some details about them. There's an awful lot of information, so I'm going to just do the basics about this very simple, very affordable mass housing and self-build housing and anything else you want to do with it, housing wall system. So it's made of 98% renewable raw materials. So that's 88% is straw and 10% is timber. So it's a box with twin stud system. So you can think about it as a timber frame system with densely packed straw in the middle. And the 2% that's not renewable are the steel screws that hold it all together. It's a very, very carbon storing construction, better than anything else. Nothing else can compare with this for a wall building system in terms of carbon storage. It's very, very well insulated. It's also vapor permeable, And because it doesn't contain any toxins or VOCs, it gives you very good indoor air quality as well. They're healthy buildings. And with this system, you as architects can design anything you want, and pretty much we can make it into an EcoCon panel system. So you don't have to work on a particular panel size. We can make things as we want in our factory. And you can be sure that everything is consistent. It's certified by independent assessors. So you always get the high quality that we expect from the EcoCon factory. This is what a panel looks like. Here it is suspended from a crane. It's you think about it as a load-bearing timber system, even though most of it is actually straw, and we know that straw is structurally strong. All the engineering is based on the timber, and it has plywood top and bottom, and it has 4 slim studs at the corners. So you see straw on all 4 sides, and the straw is compressed using a factory press, not whole bales. So it's straw that comes from the big round bales that you often see in the fields. We can make panels any width from 400 to 1.2 meters wide. They're always either 400 or 300 mil depth. The 400 depth you must do if you want to meet the passive house standard. And we make the panels up to 3 meters tall, but you're not limited to 3 meters because we just stack them all together like giant Lego blocks. Very, very easy. So you can see here the different types of panels. Some need braces, most of them don't. You can also do angles, so you can take your structure and your insulation all the way up to the gable end. And we can do lintels, we can do sills, and we can do lintels up to 13 meters long if need be, with a different system with using box lintels. So the standard wall build-up starting from the outside is generally either a timber cladding or a lime render. And you've got choice of cladding. It doesn't have to be timber, but usually it's timber or lime render. Behind that, a ventilated space, and then 60 mil of wood fibre board if you're going to meet passive house, directly onto the vapor permeable membrane, which is an external airtight layer, which again makes the build system very much more simple. That's attached to the panel. And then on the inside, we definitely recommend using a wet clay plaster system, but you don't have to. I'll tell you why we recommend that here, because the clay and also lime, which is another natural material, but slightly more processed than clay, it enhances our whole philosophy of being as natural and close to nature as possible. Clay is 100% natural, and it doesn't have any toxins or VOCs in it. Clay also does a lot of other things, as lime does, which enhance the properties of the building. They regulate the indoor humidity. They balance out the latent heat in the building. They prevent decrement, or they cause decrement delay, so you don't get too hot in summer. You stay nice and cozy in winter. They store a lot of carbon, and the clay doesn't fade. It's very easy to repair it. It's very good acoustically, and it comes in lots of different colors, and you can make different shadings of the color by the plaster techniques. Fire tests, the panel with its wood fiber board and clay on has a 2-hour fire rating. And what's really important to understand is that at the end of that 2-hour fire test, the structure of the building is not destroyed. And that's really different to a lot of other fire tests on other insulating materials, is that, yes, you get your 1 hour or whatever fire test, but at the end of it, you've got nothing left. This is a really different system, and it's counterintuitive because people have this stereotype that straw and timber are really combustible, and it just is not true. Other technical characteristics, the U value of the standard system is 0.12. It's very, very fast to put up. So 3 people and a crane can put up the walls of a 2-story, 3-bedroomed house in 3 or 4 days. That is very fast. That's why modular construction is so popular for major house builders. Unfortunately, they haven't yet got on board with this type of prefabrication, but they will do soon. It's very, very precise. So if you design something that is millimeter accurate, we will make it in the factory also millimeter accurate. And the carpenters on site will make sure that that stays there. It's really good acoustically. It sequesters 97.6 kilograms per square meter of carbon dioxide, and the density of the straw is 110 kilograms per cubic meter. So that's factory pressed, and incidentally that is pretty much the same density that a load bearing straw house achieves. So the process for ordering and for designing is streamlined. You give us CAD files and engineering loadings. We give you 3D drawings and 2D drawings in SketchUp, which also shows how the lorry is loaded and how to offload and put them all on your site in the right sequence so that you end up with the front pile being the ones you start with. Here you can see them on the building site with the color stamp on each panel and the label, which matches the detailed drawings that we sent you that we call the panel project. So delivery and unloading is always from an articulated lorry, and you can offload with a crane or with a forklift. So then you need to store it on site. It can take a little bit of rain, but we provide the membrane that you wrap around everything, which is your first weatherproof layer and can stay on for 3 months before you cover it with your wood fibre board and still give you protection. We also provide you with some plastic sheeting that can go on the inside until the roof is put on. So you need to remember this is a wall system. It's not roofs, it's not floors, but it's a very, very fast and effective building system. You fasten it together using cramps and ratchet straps and a power driver with a long bit on it. That's your main tool, and you can get it extremely precise. There's a very, very comprehensive assembly guide on the website that tells you exactly which screw to use in which location and where to start when you're putting everything together. You can't go wrong. All of the contractors we've worked with have loved it. It's just like putting Lego together. When it comes to electrics, then you can use a small router to cut gaps in the straw to put your electrics in, to sink in your back boxes, and plaster everything in just as you would for normal. With plumbing, then you need to put a service void in, so you don't put the plumbing directly against the straw. It's got certifications for all sorts of things. It's, as I say, it's a certified passive house standard product. It's also got the cradle to cradle certificate, which very, very few building products have, which is a very high sustainable certificate to achieve. It's tested with the European technical assessment, which is accepted throughout all of Europe. Unfortunately, we're no longer part of the union, but it will come back. The keyword inspectors are recognised in the UK as being independent inspectors who test the factory and the product for its efficability. And then there are lots of resources on the website. I haven't got time to go into all of that here, but we're trying to catch up in the UK. It's much more prevalent in other European countries, and in Denmark, for instance, they're working with one of the top architects, Henning Larsen, who has designed this classroom, and they did a study. They built 2 identical classrooms, one with eco cocoon and one with their normal materials, and they found that the Eco Cocoon one stored 32 tons of carbon dioxide, whereas the original one emitted 112 tons. So just like Craig said, there's a massive difference, an unbelievable difference in using straw predominantly for building with in terms of carbon storage. Nothing else can compare with it. So it's a timber frame construction. We don't use the straw in any of the calculations for engineering, although we could do. And it's CE marked, and this is going to be increasingly important post-Brexit, because we've now abandoned the UK marking system. So products that come from outside of Europe with a CE mark are going to be accepted here. And in terms of insurance and finance, you have to bear in mind, first of all, that this is still a very young product in the UK. At the moment, there are probably only about 20 or 25 houses, all of them residential, quite a few of them self-build. So these are the companies that have been proven to offer mortgages and finance for those individual houses. It's obvious that your clients are going to have to do a little bit more talking and discussion to get insurance and finance for their Eco Cocoon build, but it is possible. And as the market develops and we get bigger house builders coming on board, then that side of things will also develop alongside it. We don't have any worries at all that that will be the case. These are some of the architects and builders who are already designing with Eco Cocoon. So what's important to recognize is that we are not building a whole house for you. We are providing you with the tools and the knowledge and the expertise to be able to design really high quality houses, which can easily be passive houses, and for you to do it and for us to enable that to happen. And we're doing the same with architects as we are with builders. So builders can be the ones who put all of this together, but they're not the ones that make the panels. We do the specialist in the stuff in the factory. We've got the expertise. The company is a visionary company. It's a social enterprise. It splits all its profits between its shareholders, its employees, and other companies that are doing similar things globally. And they've thought ahead, and they now have an absolutely top of the range factory coming online in September this year, which is completely automated and digitalized. And that is the only way that you can get mass housing at an affordable price using prefabrication. A lot of other prefabrication systems have stuck at being quite small and localized. This is already a global player. So building costs are currently no worse than building with any other material when you're using the same thermally efficient system, but mostly build costs are less because it's simple and very fast, and contractors are able to adapt to it really well. And when we do mass housing, like you can see here in Switzerland, then the costs really come down. You can build whole panels and whole wall systems in a factory in this country and then bring them to site. And this is what we're going to see for the future. We're going to see high-rise buildings like this one that is being built at the moment in Sweden. It's coming in at a much lower price, a significantly lower price than a conventional build would be. And we're not able to do that in the UK because of the way that our building regulations looks at fire risk and so-called combustible materials. But so we can only build to 18 meters. But in Sweden, they are proving that you can work around those issues that seem to be insurmountable for us. And we will soon see this building at completion. So you can get lots of information from the website. It's a very transparent company. There's loads and loads of information freely available to download on how to do it, how to build. And you've got me as a resource. You can talk to me about your projects. I can do CPDs for you. I can find out bits of information. And there you go. What's not to like? Thank you very much for listening.
Thank you, Barbara. It's great. So up next, we've got Will Kirkman. So Will is the Managing Director of ACAN, a business specialized in sustainable and natural building materials for the building trade and consumers. So he recently set up We Build Eco, a building company producing energy efficient building kits from any design with a fast and precise process. Their kits are easy to assemble, and as with all the systems we've seen tonight, the buildings are natural, healthy, and sustainable. Over to you, Will.
Thank you very much. Just share my screen. Sorry. I'm hoping that, can everybody see that? Have I managed to get that right? Are we there?
Yeah, it's good.
Yes, we can see that.
Okay. Thanks very much. Well, I don't know whether, I think most of what I'm going to cover, I'll just be redescribing a bit like Mexican food, I suppose. It's the same ingredients, just folded differently, which is a bit unkind for, but I think I'll probably just like to start by just explaining who we are, because We Build Eco is actually, it represents a group of companies who got together. There's ourselves as Eco Merchant, there's Styco Manufacturing, iJoist and wood fibre installation, a company called Kithurst Homes, excuse me, where the factory is located, who are a company that originally a building company that moved into manufacturing, and a structural engineering company called Build Collective, who many of you might know, based in Bristol. And we were already supplying into many people who are building with an iJoist system with natural insulation. And it was getting more and more difficult to explain it to people. So what we did, we effectively wrapped it up in the brand of We Build Eco. So We Build Eco represents a building methodology, a building system, a way of building, and it is a bio-based building system. What we actually provide are effectively kits. So this is more along the lines of, think IKEA. So we will sell you the components as a kit for the design that you have. Sorry, excuse me. So we don't design anything. What we do is we will look at the designs that other people have. We will convert them into an iJoist structure, and we will provide engineering services and design services to allow the system to be designed within as a fully compliant system. So it's based on an iJoist system. The insulation materials are all naturally based, but they can be of different varieties and different types. Pretty much any shape, any building, but inherently passive. Again, like the other systems, this is a system that lends itself to passive construction. And where we start is we start when you're up to ground level, we will begin, and we will finish when the building is weathertight and airtight. So basically, we will design the building for any design that we have. It has many of the features that the other systems have, which is where it's fast. It's a fast turnaround. The machines themselves are not actually the limiting part of the process. It is the packing and the loading that takes it. The machinery that we have can cut incredibly quickly. It ends up with an easy to assemble kit with very, very little waste. Again, it is millimeter. We're working to tolerances of millimeters over the whole build. So when we look at a building, and we've looked at buildings that are tiny, I think that the smallest ones that we've done have been about 15 to 20 square meters. We talked to lots of builders who are interested in this, as well as architects and building designers. And we have built, and we are building some much bigger buildings at the moment as well, including agricultural buildings that we're looking at building. So we take the drawings that we have. We work in CAD works, so we do everything in 3D. The output from the 3D from CAD works goes to the computer. So whatever is output from the 3D plans will be what is cut by the machines. And so we spend quite a lot of time where we can making sure that the translation to a 3D drawing is absolutely accurate and fully compliant in every way. We talk to people at lots of different stages in their build. We've had, and it might be for various reasons. We have quite a few where access is an issue. As these come in kits, they can be sent on smaller wagons. They get around some of the access restrictions that larger sites can present. But pretty much, as long as you've got that internal line that describes the floor area, and we've got rendered drawings, we can take you from an idea right the way through, right the way up to plans that we get sent for construction made using other build systems, maybe block and brick, maybe ICF we get occasionally. But we will talk to you with the plans, and then we begin the translation process into 3D to turn the building into an I-joist building. The machinery that we have on the factory in the UK is incredibly precise. And also the interesting feature for this is that it'll also apply printed. You can see it in one of the slides coming up. It actually marks up all the timbers where all the connections are made, and then that will link to the drawings that we send out, the construction drawings as well. The kits are supplied not only with the I-joists and the insulation, but the internal boards, the external boards, the membranes where required, all the air tightness tapes and accessories, and all fixings. And we also have, for almost everybody except some of the more seasoned builders who are using the system now, we will typically train you for the project. Even on the smaller ones, we will train you on how to put the building together. So the gap in the market that we were kind of seeing, I think, while we decided that we wanted to do this, was that we were talking to an awful lot of people where building offsite was difficult. There were bigger companies that were doing offsite construction, but it was their designs, their builds. These were the much larger end of the market. The smaller end of the market found this inaccessible, and there were hundreds and hundreds of building companies that we bumped into over the years who would love to build using a much more sustainable and natural way of building. And this seemed to us the most sensible way of providing something for them to be able to build. So a lot of our customers are smaller building companies, smaller local building companies, who are now finding it accessible to actually offer their customers and to deliver buildings which are more energy efficient and more sustainable. So once we've managed to cut a building, or you can see here, we've got some connector plates and we've got some LVL and we've got some I-joists, and all of them come marked up. All of the markings, of course, relate specifically to a section on the drawing, a bit like Barbara's presentation. We put onto the lorry that's delivered to you, we give you a load list and an offload list so that you know where to start and which part you're using first. Really just simple things that where timbers and we have intersections and connections with building, we always mark with 2 lines so that you know that the connection goes in the middle. And we will, throughout the process of engineering the building, we also will have chosen and specified for you all your connections. So that will be any of the fixings and the screws that are needed. They will be identified on the plan as being located to a particular place on the drawing, which will be written on the actual timbers themselves. So one of the things that we learned very quickly that was popular with the smaller construction companies is the fact that waste is minimized. We had, in the early days, 2 years ago when we started all of this, we were having builders who were used to ordering multiple skips for sites. And that was one of the first things that they picked up on, was that they were able to build with far fewer offcuts and waste. That would normally be the boards. But then again, with the insulation, either if you're blowing, there's almost no waste at all there. And if you're fitting friction fit bats or you're fitting external boards, then often you can find a home for the smaller bits and pieces, so you minimize the waste. The other feature, which I think is we've seen as well, where we've had infill sites, certainly in urban areas and more metropolitan locations, is the fact that this can be built by 2 or 3 people without the use of a crane. The other thing is that I would say is that we've picked up on is that as long as people on site can read drawings and can use power tools, you're not after highly skilled carpenters to do this. This can be done with people who, through the simple application of reading plans, following instructions, and applying common sense. And we find that we can dispel a lot of the anxieties that anybody might have if we train them, or if we run open days at the factory as well. So the open days always involve practical, and I think it pleases people just how straightforward and simple the system can be. The bio-based materials we used are principally wood. We did a job in Scotland recently where they wanted to use wool, and they used the Scottish grown hemp. But it will be a timber I-joist building. The internal vapor control layer and structural element will be a modified P5 board. That's the one in the top left-hand corner. That's a vapor block board by Unilin. Wood fiber bats can be friction fitted on site. And then we have wood fiber sheathing boards that we can use externally, principally to get the thermal performance that we want out of the building. So again, everyone else has been through this, but I think this is fairly obvious to all of us that we're all trying to get into the same space where we're using materials that are less polluting, less problematic, less toxic, that give us fewer issues, that perform in a particular way. So we are naturally, by using natural materials, we end up with a more vapor open building system. We end up with better, we can match U values quite easily. We can achieve the U values that most people want. We get excellent phase shift. The phase shift of all of these buildings use natural insulation. And that's critically important as well, where you've got where you're living under a roof, or where you have walls that are exposed to long periods of sunlight. So this whole idea that we can build using all of these materials to give us a durable, long-lasting building does have, and we are finding and uncovering, really significant appeal amongst many people who you might have considered wouldn't have been that interested even a few years ago. That's a picture of the factory. It's down in Sussex, in West Sussex. You can see the farm buildings. It's quite an extensive factory. There are plans at the moment we're looking at to extend the buildings and to extend the capacity as well. The factory, once the machines are running, takes us about 4 to 5 hours to cut a 90 square meter building. However, it takes us a little bit longer than that to pack it. We only package and strap using steel, which can be recycled for the banding, and wood bearers for the transport. So we're trying, wherever we go, like the others, we're trying to minimize waste and to allow where we do have things which are disposed of, where they can be recycled. One of the other things that we found quite early on was that there were a considerable number of companies, especially timber framers and smaller ones, who would use us to extend their business, so that they had many of the skills that they required to design a building or to erect a building, and they could find customers, but they were limited sometimes by, it might have been their storage capacity, it might be their construction capacity. And we found a number of customers have returned time and time again to add an extra building to their capacity. Maybe instead of selling 4 or 5 houses a year, now they can sell 7 or 8 houses a year. So we've allowed other people to as well to expand the market. That is who we are. We have a website, webuildeco.com. It's pretty comprehensive. It covers pretty much everything that I've talked about here and much more. So if anybody's interested in having, by the way, if anybody's interested in visiting the factory, if they're in striking distance of it and they can make a trip down, then we're very happy to have you. And we do run open days and events, and of course I'll let ACAN know when we have the next one planned, and we'll send out an invitation. And that's the case. And that is me rattling through my slides, I believe. Yes. I stopped sharing my screen.
Thank you, Will. I think we'll have Tom now chairing the Q&A. Over to you, Tom.
Great stuff. Thanks. Amazing talks, everyone. Sorry about our techno boo-boos earlier on, but I hope yeah, we've got a few more of you here. Right, I've got a long list of questions for you all here. Handily, they can kind of, I think most of them be answered by any one of the three of you. So take your pick. So the first question came in at the start. It is a broad one relating to the nationwide housing shortages or shortage. To what extent can modern methods of construction answer the national shortage of housing or providing high density apartment blocks or buildings? I think, Craig, you answered something in the chat, so maybe you want to start on that one?
Yeah, I think for affordable housing, it's around land supply, because if you're competing with commercial house builders on land, then that becomes a challenge. And one of the things we do is unlock land. There's some legislation called the Custom and Community Housing Act 2015 that obliges every local authority in England, sorry if you're in Wales and Scotland, to create a land supply, technically called the Land Register, but local authorities kind of give it lots of different names. And if you're interested in being a custom builder, as government definition, newly created, or about 8 years old now, to describe self-builders. And every local authority has to create a land supply that cannot be sold to commercial house builders, so they're ring-fenced. And that every local authority has to match a land supply to demand. So if you get on the housing register, not the social housing register, but the custom build housing register, they are legally obliged to match the supply. So the first lot of land was the good, the bad, but mostly ugly, and lots of little bits of land, but that they've flushed that through now. And so there is higher quality land. And then the other one is working in communities. It is much easier to collaborate with people than it is to try and find the land by yourself and do the build by yourself. People do it and it's fantastic, but it is not the easiest thing in the world. But others may have different kinds of answers. And the build systems is kind of a hardware cost. They're mainly a kind of fixed cost. Well, things can vary, but it'll be the kitchens and bathrooms and glazing that will change fundamentally the cost of the building, not so much the walls. And as soon as straw scales, then the cost per square meter will become more and more affordable. But it's land that unlocks affordable housing.
Yeah. Barbara, Will, do you want to comment on that one, or should we?
I don't mind.
Yes,
I think
what I'd like to say is that for us, for ACAN, we're not competing with the developers. We're talking with the developers because we can help them to build cheaper. As soon as they start building with ACAN, they can do the same designs, but with different wall systems, and they can bring the whole thing in cheaper. So land prices is definitely a problem if you're a self-builder or trying to build something one-off. Our vision is to really get to grips with the housing market and do something really, really big and make change happen.
Will?
Yeah, I mean,
we can move on. There's lots of questions here.
No, move on. Don't want to get into the developer argument. We'll be here all night.
Right, okay.
Flag, we've got 24 questions, so just kind of keep it quite down.
Right, okay. Let's start pushing through then. Right, much talk in Scotland, as elsewhere, I'm sure, about affordable housing. This is that is usually provided by government subsidy. To what extent can these systems be affordable by design? Close to the previous question.
It's about scaling, isn't it? It's a scaling question again. So it's an interesting thing. One of the things that we encounter is that people want to build using a system that's more natural, more sustainable, and they look at it. And we all have to be relatively competitive. You know, there's not a big gap between, you know, when you compare the build costs, you've got to be there or thereabouts. If you're considerably more expensive, then somehow you have to justify it. But I think the other thing is that we're all making construction, we're all taking cost out of it. We're trying to limit the cost. So it's who gets the benefit. You hand that benefit to a developer, it's paid to the shareholders. If you hand it to a housing cooperative or a company, then they're more likely to make the end result more attractive to the end user. Scotland is a really interesting one. 80% plus of all houses in Scotland, new houses in Scotland, timber frame. So it is an easier market, Scotland. I have to say, it is a particular region, and we're actually currently just in the process of opening up a new business, a new location in Scotland, simply to be more Scottish and address the timber frame market.
Right. Let's push on. Right, we've got a question here that I think I can answer myself. Is there an alternative to concrete foundations?
Oh,
Watch
yes.
our YouTube video. Low carbon foundations. It's on the ACAN YouTube website, so look that up. Links in the chat. But Will, Barbara, Craig, do you want to have a stab?
Yeah, I've specialised in designing cement-free foundations and have been doing that since 1996 and getting them through planning and building regs. It's essentially the way that everybody used to build before 1920. So, you know, there is no excuse for building with cement in foundations anymore. We've just designed a fantastic raft for a new build eco-cocon house in Driffield, which is on really weak, poor quality ground, and it has no cement in it whatsoever. And we hardly touch the surface except to take the topsoil off and level it.
Right, fantastic.
And then we have a rule: no concrete until we can't use anything else. So we use ground screws, we use pads, and then we've done lime slabs as well. I mean, the key thing with prefabrication, you can prefabricate the floor. If you look at an old Victorian house, it will be a drafty but floating floor with a ventilated void underneath, and as long as you manage the ventilation, then you can prefabricate your ground, but you can't push organic materials into the earth. You have to design differently around it to give the ventilated space. Those would be the.
I would concur. We're the same. If we've got a design for some block and brick houses already there, then we'll go off the concrete. We'll go what's there. But if you're starting from scratch, then I would absolutely agree that screw piles seem to be enormously popular with our customers.
Yeah, they've got very well known, but there are lots of other methods that don't need steel.
Yeah, fantastic. And then for a little plug for one of our ACAN crews, Jana's current live on site prefab build is being documented on Instagram. And that's a screw pile scenario which you can see that all live up there. We can put that in the chat as well. Right, more structure queries. How are roofs connected to straw panels, and what are the typical roof connections?
It varies depending on the nature. I'm sure. So we do prefabricated straw roofs. So that's easy. So we engineer all the connections for that. Flat roofs can also be done in straw panels as well. But in effect, you can actually bring your walls up. If it's prefabricated, there'll be a head to that. You tie those together, and then you can put any combination of roof on top, depending on the thermal performance you're trying to achieve. But we prefabricate our roofs as well. Not every budget can afford that compared to a truss rafter, for example.
Yeah. Eco-cocon?
So with Eco-Cocoon, like I said, it's a wall system, and we don't build houses for you. So it's something that an architect would design and a builder would put together with other elements. You could use roof cassettes. you could use iJoist with other forms of natural insulation, but generally it would be an iJoist roof, and it fastens to 200 by 100 timber wall plates that attach through the top panel into the studs of the timber frame of the panel below. It's there are details of how to do it on the website.
Yeah, oh, that's fantastic. Don't know if you want to speak on that one, Will, but we can
Don't
push
do
on.
straw.
Yeah, right. So how tall can buildings made from straw panels go? Is there a story height limit?
I think Barbara answered some of that, but in the UK, we are also subject to progressive collapse, as well as the tragedy of Grenfell now changing the way in which you can use combustible materials. Under progressive collapse rules, any build system, whether it be steel, concrete, timber, straw, or otherwise, is 3 floors plus a roof. Once you go above that, you put in a separate frame. So that would be a glulam frame with your straw panels actually being non-load bearing at that point and clipped on. And then, of course, the 18-meter rule in London is challenging, but there's lots of really good work being done to look at how the definitions, safety is paramount, clearly. The annoying thing is that there was no wood burnt at Grenfell. It was all fossil fuel based cladding and insulation. The only wood that played a part at Grenfell was the fire doors. But anyway, that's me preferencing materials.
Yeah. Right. Okay. How structural openings then? What are the structural opening limits to any of these systems? Right. Barbara, Will, do you want to?
Yeah. So we can make eco-cocoon lintels up to 3 meters long, but we can make box lintels that are 13 meters long, which should pretty much solve everything for everyone with whatever size you want to do. So there's not those are the sort of limits. If you want to do windows that are more than 13 meters long, you probably are going to want to have some sort of support system within that.
Yeah.
Unless you're absolutely a billionaire with those sorts of ideas.
Likewise, sorry, Barbara.
No, it's fine. Go on, Will.
I was just saying, likewise for us, the span width is determined by the size and the flange width and the depth of the iJoist, and the span tables, which will allow you to calculate it. But you can go pretty wide. What will normally stop people is just the sheer cost and frequency of the iJoist that you're putting in. But a 90 flange iJoist can be 400 deep, and you can span it in 7-8 meters, no problem. Right. But so for most of the regular openings in the buildings that we supply, we will engineer the openings using iJoists, and we won't have a problem.
Great. Right, I'm gonna have to push on because we've got a load of questions here, and I'm getting voices in my invisible earpiece. So fire is a big one that keeps coming up. Fire rating of straw prefab panels. Can it be used on a site boundary, or does it need to be a distance away?
Of course it needs to be a distance away, because the planners tell you it has to. It's
the law.
It's just sensible. If your house goes on fire, you don't want it to jump onto next door's house. They'd be very upset.
Yeah. Mortgage issues, current situation, mortgage insurance on wood framed or wood exterior homes. Maybe comment on that.
I think
the key thing around this is certification, and a lender wants to be assured that the building will last a minimum of 60 years. So the design life for a mortgage lender is 60 years. That doesn't mean it falls apart, but that's 2 mortgage cycles plus 10 years. They want two and a bit bites of the mortgage cherry. And at that point, it's about the certification, which can either be done by the product provider or the designer or the engineer. And that can also be done by what used to be called architect certificates, but now more commonly known as consultant certificates. With the Ecology Building Society, we've done prepackaged mortgage finance with them. It's particular to us, but there are 3 other providers that Ecology will do that for. I put the link. It's buried in the chat. Some 100 questions up the list.
All I'm going to do is agree. It's always the same names. It's Ecology, it's Build Loan, it's Build Store, it's various other people. We occasionally come into problems. We came into problems with a customer in Scotland who wanted a timber roof, so the whole building was timber, inside, middle, and outside. We had a few issues there. And the fire issue when it comes to proximity to other buildings, yes, but these can normally be managed. We're doing a job at the moment where we're managing it with a board being applied to extend the fire rating. They can all be managed out. But I think what I would say about this is there's generally speaking, there's a sort of, oh, you're going to have a problem getting a mortgage, isn't this? You know, there's a lot of perceived risk and there are a lot of perceived issues. And oddly enough, there is an ACAN working group looking at mortgage providers as well. And so I'll see if I can dig some more on that. It's painfully slow to get all these mortgage companies together and talk about this. Mm-hmm. But what we've discovered is that a lot of nonsense is talked. When it boils down to it, if Persimmon, the biggest timber framer in the UK, can lend on all their houses, then there's got to be ways of doing it, even if it means skinning part of the building with render or brick slips or something else. But pretty much, these are often misplaced anxieties that we can, just working through them gets rid of most of them. Brilliant. You can end up building more or less what you want in most cases.
Yeah, I agree. Well done.
Good stuff. Right. So other end of the spectrum, query wise, do the straw panels cause dust over time within the house? Are there any issues with cleaning clay plastered walls? Yeah, try those guys. Barbara?
Dust, no, because you don't see the straw at all. It's completely covered with a plaster or a board.
And then with that clay plaster, can you wipe your clay plastered walls with a damp cloth?
You can't wipe it directly with a damp cloth. Well, you can, but generally, if you want to be able to wipe things like in a commercial kitchen, then you would coat it with a linseed oil paint or a proprietary paint specialised in for clay plasters that you can wipe down. And there's a new a powdered lime paint called Farnovo, which is also wipeable, that you could paint it with as well.
We have a French clay plaster manufacturer who supplies us, and his trick is to bring a bucket of clay plaster which has gone rock hard to a show, re-wet it and rework it. So clay, unlike lime, you can rework clay and you can re-wet it. And they also use carnauba wax. They use various different waxes and different additives to give you a different finish. And it's highly architectural. It can be really, really lovely. And lime, of course, lime and clay, both more forgiving in terms of movement over time.
Right. Another one, about buildability of these systems. Cables and pipes, how are they integrated? Or do they need to be surface mounted?
I think Barbara showed how one method, for sure, you can either build it into the face. It's easier if you're rendering with lime or clay to do that. You can build it in earlier. Or if you're using a fully closed panel system, you create a service void on the inside between the difference between the panel itself, the core of the wall, and then the final finish with we don't use plasterboard anymore, but Thermocell is a similar board. So if your finishes aren't, if they're applied to the surface of the straw, then you're doing your first fix in the straw face. And I think all of us have done variants of that in different ways.
I think the other service that I would agree, similar but with an iJoist, and the other one you do need to look at, and we like to engineer from the start, is MVHR. So with an iJoist system, if we've got an MVHR system going in, then we can pre-cut, or at least we can mark out all the templates. And there are lots of guides that we can provide so that holes can be cut on site, so that you're only removing the amount that you need for the MVHR system. So don't forget intermediate services between ground floor and or in the roof where you've got ducting for your MVHR system as well.
Yeah, that's a good point, Will. The EcoCon factory can actually make the holes through the straw for you for your ducting if you give precise locations.
And, it's the beauty of 3D engineering. It's the beauty of drawing everything in 3D. is that, you know, you pay a little bit of money up front to have your drawings converted into 3D, and it does help reveal issues and problems that you can then solve on paper before you commit anything to a saw.
Yeah, it does.
Right. Cool. Right. So I'm going to crack on through with some queries about some specific project here. Someone is asking whether they would value a conversation with us about whether we can advise on developing care homes using low carbon or natural materials to passive house standard for local authority. They've got 2 passive house developments on site due to complete in 2024. Construction is currently brick, block, steel, or concrete frame, but they'd be interested in reducing embodied carbon. Yeah, and
well, they'll certainly do
wider
that.
benefits. Most likely DNB contracts with procurement to commence from REBA stage 2 in Q1 2025. Thoughts on? Yeah.
Well, we can do that straight away. If we can just swap out what you've got that's building your walls and put the panels in. We've done that for quite a lot of projects that have decided they want to be sustainable instead of normal modern housing.
What I haven't said with ours is that we also we do produce panelized products. We don't like doing it. We prefer to do the kit system. That's where our market is. It's where we're attracting most business. But also we work with glue-lam and LVL structures as well for larger structures. So there's probably some of the things that we haven't told you that We Build Eco can do and do. But I think the answer to the person's question who's asking is any one of the systems that they've seen tonight would probably be able to fit, depending on the size of the building. Did they give us a clue about how big this building was, or did they just say big?
It's not in this query, no.
Okay, so we go back to refer everyone back to the 18-meter rule and what Craig said earlier on about the size of the building. But yeah, I'm presuming they're going to be quite large if it's a care home.
At this stage, if it's D&B, and if you are the writer of the specification or the influencer of the specification, you cannot nominate a particular supplier. And we've done this a number of times with clients who want to go through contractual framework processes. You can actually just write in, we seek to get proposals that decarbonize the build systems using biogenic materials. You can put in, you can actually write that in, and then you might have 5 or 6 contractors who bid for it. And if they're smart, they'll go and do their homework and go and find Barbara and Will and others for that. You can write a specification really cleverly to make sure you get the right outcome. But if you're designing for steel and brick, you also have a client who will have a budget. So there's a cost spectrum as far as the client is concerned, and also change. But I would write something into specification around decarbonisation using
I 100% agree,
and send them off to do their homework.
Yeah,
I 100% agree.
Great stuff. And I want to ask about the opposite end of the spectrum for a single 60 square meter, single story self-build. Apparently, most companies are saying to this questioner, especially the EU ones, that they are not interested due to the small size and limited budget. For one-offs, is timber frame and something like hand-cast hempcrete always going to be cheaper than prefab systems? 60 square meters.
I mean, 60, 70, 80, 100, 120 square meters, it's annoyingly small for people who've got big factories, but it's kind of what we do. You know, so I would say, look at it. The whole discussion about how you compare prices, it begs the first question is compared to what? The next question is it's all, you know, you might think that something's too expensive. I'd rather pay a little more and get something that does what I want it to than pay too little and have something that doesn't do the job I wanted it to do in the first place. So, but I think, you know, we all have to be competitive, don't we? I mean, we can all use estimated pricing. We can always look at it. So, you know, okay, so can we do this for £2,800 a square meter? No, well, we'll do it for 3,000 a square meter. Okay, that's the ballpark. So I think that the question is ask. The answer to the question is ask. We can't give you a price until we've seen what you want to build, but we can give you an estimating price pretty quickly. And we don't often say no. I think the smallest job we've ever done was 15 square meters. And that was for an architect. It was for an extension on his kitchen.
I think though that there really what you're talking about is, should it be pure self-build or should you do some prefabrication? And if you've got the time, then self-build is almost always going to be cheaper.
Yeah.
Whatever you use, whether you use small bales, whether you use hemp, whether you do timber frame, you know, that's why it's self-build, because you put your own time in and cut that out. Prefabricated panels, the time is paid for in the factory.
You're not paying a developer margin if you're doing it yourself either. So, I mean,
Yeah.
there are other people taking a margin. If you ask someone else to do work for you, they'll take a margin. Fair dues. They're giving you something in return. Those margins add up. So it's about being smart. You know, we know that we can always make some assumptions. Getting out the ground is going to be more expensive than you think. It's a fair point. But we've already been through the ways that might be mitigated doing this. Yeah, so it's being clever about where you spend your money. But you know, if you're aiming for high-end performance, if you can get the building shell done, you can always put, you know, a better kitchen in later. But it's really difficult to retrofit. You don't want your project to become a retrofit on day one, the day you get the keys.
Right.
I'm just liking some of the comments.
I'm not reading them, I'm afraid. I can't see.
There's
Well,
yes,
we're
I mean,
going to get our heads knocked together, and Barbara said we're already doing it.
I didn't mean we're getting our heads knocked together. I mean, we are collaborating.
Indeed, yeah.
I think that's
so I just read that out. So
yeah.
To what extent might the three of you knock your heads together to aggregate your learnings? There you go. So you're all party to that query.
We all learn from each other all the time.
Absolutely, yeah.
It's the whole
done research.
The whole thing about it. It is, you know, the nice thing about all our businesses, We Build Eco is a collaborative endeavor. Agile is a collaborative endeavor. You know, Barbara's been involved in collaborative endeavors for years to get people to change the way they build. It is the way to do it. We're not going to just turn it. You never get. This is why L&G never did natural insulation for their big factory that eventually went fucked. You know, it's a different system. I mean, look at it another way as well. Is custom and self build will be the biggest builder in the UK if it was one company. Okay, so the more people we can get together to work together, the better. But to answer the person's question, we do talk to each other a lot. Great,
good stuff. Good to hear. Right, another one that I'd like to ask is about the fact that the application of these systems shown this evening seem to be predominantly domestic. But can all of your systems be used in other sectors?
I think we'd all say yes to that. We've done schools, we've done offices. Housing is the big demand, especially affordable housing and sustainable housing. But we've done 4 office blocks, about 5 or 6 schools. So yeah, all of us would say the systems can be used, and Barbara was showing some amazing work in Sweden on height and some of the larger projects. So there isn't an essential barrier to these build methodologies being used in particular ways, especially below in the UK at least 3 floors plus a roof. Outside the UK, you can go higher. But that's just. I would agree as well.
We do a lot of. We're on site with another school this week. We've done a lot of school buildings, a lot of health buildings as well. But it tends to be habitable buildings. I don't think anyone's asked us to build a warehouse using an I-joist system, but we are looking at building commercial structures using glulam and mass timber. But that's a different thing. That's not really We Build Eco.
Well, ACAN have built their own new factory out of their own product. So there's no limit really. I think part of the problem is that we're so far behind here in the UK compared to other countries with prefabrication, and we've still got a way to go. But just look at France, look at Finland, look at Norway. They're all doing really amazing things, and we're going to get there with all of these different systems. There's room for everybody in the UK market because our our claim on that market is still less than 1% in terms of house building and commercial building.
Fantastic. Right. Thank you so much, guys. I think, although that I could, there's questions here to keep you here all night, but I think people are tired and dropping off in every sense. But thanks so much for the conversation, and I'll hand back over to Anna, who's going to close us out this evening.
Thanks, Tom, and thanks to our speakers, and finally, thanks for everyone for coming.